Good evening. My name is Stuart Reed. I'm Vice President of Engineering for Corsa Technology. And today we're showing a demo for a SDN BGP router. This is a joint presentation of Corsa Technology and ESNet. So, Corsa Technology, we're a relatively new company, and we're delivering a new kind of product, which is basically a data plane specifically designed for software-defined networking. It is a device that allows you to do flow forwarding at internet scale. And it's a device that would sit in virtually anywhere in your network. It can be an L2 switch, it can be a load balancer, it can be a firewall, and what we're showing today actually is an L3 router, specifically a BGP router. We're working in conjunction with ESNet. ESNet provides research institutions, educational institutions with a US-wide network with advanced connectivity and services. So let's talk a little bit about, whoops, we'll show the first slide, I missed that one. Talk a little bit about BGP routers. So BGP routers are very core, very key to the internet today. They provide basically connectivity between autonomous systems within the internet and allow you to route traffic between these systems and basically get your end-to-end traffic as you would like it within the internet. There is certainly a high degree of frustration with BGP routers today. The setup tends to be pretty static. You have to assign weights to the connections, and that's how BGP uses this information to establish routes and to route the traffic. But unfortunately, as an operator, you set these up, it's pretty labor intensive to set it up, but then you don't have a lot of fine level control or a lot of visibility into what's going on. And so this is where an SDN BGP router can come in, because obviously SDN, one of its things that it really brings to the table is a lot more control, a lot more programmability. And so if you're able to use an SDN router, BGP router, then basically you can get that fine level of control. So certainly we get this need where we need these routers that have policy awareness at scale. And that scale is very important. As we talk about devices that need to come sort of out of the lab and into the real world, then you really need a device that can handle hundreds of thousands, 500,000, excuse me, to 1 million flow entries in order to do an appropriate job of routing through the internet. And so this is what the solution is. Excuse me. Is this massive fib table, allows you to enter the number of routes that you need, and then because it's SDN, you have that level of control, is that you can basically make fine-tuning your policies, and they can be based on time of day, peering arrangements, SLAs, etc. And so you have a lot more control, and you have the scale necessary in order to be part of a large network. So now we'll just talk a little bit about what we're going to demo today. And so what we have is a group of autonomous systems. So we have our programmable data plane, and it is talking to a controller. Specifically, it's Van der Vecken, which is based on Quagga as the routing stack and sitting on top of Ryu. And so it will basically be the Terminate BGP. What we're using to emulate the internet essentially is a Spirent test center. It has 4 autonomous systems that are set up. And once we switch over to the demo, what we'll do is basically those autonomous systems will announce their routes, and then we'll start to have traffic flowing on those. Obviously a little bit about SDN, so it's splitting the control plane from the data plane. Our box is the hardware, it is the data plane. We're using this controller that sits on top of it. And so basically the data plane, it routes the traffic based on how you program it, what you put in the flow tables. And so you can do, as the packets come through, you match them, you can perform actions like route it to another port, you can push POP VLAN tags, MPLS tags, or you can send that data to the controller. And so in this case, the controller will be set up so that all control packets will be sent up, all control packets that are part of a protocol will be sent up to the controller. The controller will terminate them, and then in this case it will act upon them if they're BGP control packets. So we'll switch over. So on the left-hand side, we have the CLI for the test center, and on the right is simply the console output from the programmable data plane. So pretty straightforward. What we're going to do is we'll just start the devices. So there's a first step. So this is starting the autonomous systems that are connected to the programmable data plane. And what is happening now is they've established BGP connections with the controller. And so now the controller is pushing flow mods based on how it wants to program the fib table. And so now it's pushing those flow mods down into the programmable data plane. While it's doing that, I'll just switch back and we'll talk a little bit about the data path. So these are this is the pipeline, the data pipeline that exists within the data plane. And as part of OpenFlow 1.3, you can define multiple tables. And so what we have here are multiple tables that break the problem down into smaller segments and then create the sort of the overall path that the packets need to flow through. This first part of the data plane is not really used all that much in this demo, but it just shows that you can do multiple things in a given data plane, and it's about normalizing the packets that come in. And so had the packets been VLAN tagged or VLAN or MPLS labels applied, then they could be removed appropriately before it passes through the fib table. So here's the fib table, which is basically how you want the traffic to be routed, and this is where you get the scale. So this is, can be half a million, 1 million or more entries in order to get the appropriate routing that you want to set up within your autonomous system. Now we'll flip back. So the autonomous systems have now finished. We finished pushing the routes into the programmable data plane, and we will now start traffic. So what this does now is, so the autonomous systems now are starting to route traffic from one to another. So if you remember from the previous slide, there are 4 autonomous systems. They're routing traffic to one another. The test center is making sure that the routes are basically as programmed, and so it's getting out on the ports what it expects. And so if we have a quick look here, apologies. Screen's a little small, but basically as we look across here, we see that there are no errors that are being generated. So basically the test center is reporting that the data is being passed through with good fidelity through the programmable switch. So in a nutshell, that is Corsa's demo along with ESNet. So obviously we've gone through a lot of data. You know, it's a pretty fast demo. You're more than welcome to come and talk to us either afterwards or come see us at booth 75. And just want to highlight that this is a system that ESNet is starting to deploy. So again, they're running a very large network, and we're able to basically allow them to play a big part in this network and communicate with their peers using an SDN data plane. So they've been. It really allows them that, as I said, that fine level control at the scale that they're operating at. And so again, that's the important message to take home, is really that scale. And obviously with an SDN router now, you can move from being just sort of a static setup to being much more proactive in terms of how you control your network. So thank you very much. Thanks for your time.